Could you unpack for us, Robert, what it means for AI systems to generate and understand causal narratives? How does the word narrative fit into all of this? What does it mean for it to be causal? Yeah, this seems like kind of an interesting starting point.
Yeah, I mean, I think when Pearl was saying that, he was looking at the chapter in the book, it's the last chapter that is looking at the kind of intersection between causality and foundation models, namely, in this case, large language models. And I talk a little bit about multimodal models as well. And, it's interesting because I think the first time I got the inkling to write the book was after reading his book, The Book of Why. And he has this, so most of that book is really kind of bread and butter causal inference, but written for as a popular science book. But he has one snippet in there, very short, but it talks about what it would be like if there were a robot that could understand causality, if there was an artificial intelligence that had the ability to do causal reasoning. And it was a cool example. It had to do with a robot waking you up in the morning because it decided to vacuum, and then you were upset about it, and it had to understand why you were upset in order to improve its behavior. And I was thinking to myself, well, like, yeah, and what else? And it was so I said, okay, well, we need a book that's really taking an AI approach to looking at causality and is using tools like PyTorch to actually write algorithms. And so that's kind of maybe that was the point that the book was initially conceived.
Very cool. And so the concepts of causality, it seems to me like they should be more intuitive and analogous to human reasoning than something like correlation. And so, like in that example that you just gave there, where you're talking about a vacuuming robot, uh, when a human or even when my dog makes a mistake, it's pretty easy for us to have an intuition around what's causing that. My dog knows that I'm annoyed at him because he's barking. He knows that I'm not just arbitrarily annoyed, and he knows that if he stops barking, I will stop saying stop barking. And so there's this. So animals seem to kind of intuitively have these built-in systems for understanding causality. Um, Yet the AI systems that we've built up until now, they're dominated by correlation-based learning. So why do you think AI systems developed like that, and what's stopping it from adopting more causal building blocks?
If we think about, if we look at traditional causal inference, as you might see in a econometrics textbook or a causal inference textbook that's targeting people who work in epidemiology or taking more of a statistics approach. And so these models are very much rooted in classical statistics, and they're thinking about, okay, well, we have there's some kind of causal relationship between these variables, but there might be some confounding, which means that they might share some common cause. Statistical association is coming both through this causal relationship that they share, as well as through this common cause. And we want to figure out how to distill the statistical association coming from a direct causal relationship from the overall kind of background noise of statistical dependence that includes that causal dependency as well as a non-causal dependency through that confounder. And, and so that's everything I just said there is very kind of statistical language, right? And packed in with some causal assumptions about the structure of causality between these variables. And as say, insofar as we do have some use of, say, for example, deep learning and causality, it was still very much based on this kind of basic problem of having this kind of statistical association that's due to causality and due to non-causal relationships. And then and then what deep learning was doing when it was introduced into this space was to say, like, well, let's make sure we can scale it up with more data and work with, say, nonlinear relationships, maybe work in higher dimensions, etc. But still basic underlying framework. Now, kind of going back to your example about how humans or animals reason about causality, there is a space in research that thinks about this thing a lot, these types of the ways that animals and people reason causally or otherwise quite a bit, which is in cognitive science, right? So in cognitive science, researchers try to understand, hey, how is it that people are reasoning about cause and effect? How are they making causal decisions? Um, how do they understand why some outcome happened? In other words, what is the cause? What are the causes, or what is the main causes that led to this outcome, etc. And it's a fascinating area of study because it's less about understanding actual ground truth, right? So, for example, if you think about causality in practical terms, let's say that there's a pandemic and people are sick, and I want to propose a vaccine that's going to help people. Well, you really want me to be right, right? If I say that there's a causal relationship between administering this vaccine and people not dying of this illness, the burden of proof is quite high, and so we're looking at that same type of rigor that we take in statistics, that we maybe thinking about statistical hypotheses tests, thinking about falsifiability, etc. But in this cognitive science field, the question is not what's true in the world, but the question is, how do we write algorithms that do what we think is happening in those people's heads, or in those animals' heads? And it's an interesting space because it turns out that humans, despite what kind of conversations you might have at your Thanksgiving table, humans reason really well about causality, relatively speaking, especially about what some call intuitive physics, right? Like you mentioned your dog, right? Like if you walk into a room and there is something has been knocked down off of the table, and you can see some evidence about the spread of the debris on the floor, you might make some pretty good inferences about whether it was your dog or your kid that knocked it down and how it was knocked down, etc. Similarly, humans tend to be really good at what some call folk psychology, which is to say, you and I could be sitting together in a cafe and watching people across the cafe having an argument in hushed voices, and without actually hearing what they're saying, probably get a good guess about what it is they're arguing about, at least the theme about what they're arguing about. And so, so there are certain domains where humans tend to reason about cause and effect fairly well. And so one of the interesting things that we can talk about from an AI perspective is to say, okay, how can we write algorithms that emulate those reasoning processes to kind of, but this is in contrast to, say, classical statistics, which is much more concerned about, type 1 error, a false positive.